Good morning, everyone. Today, we'll be discussing an interesting string manipulation problem, which focuses on reversing only the vowels in a given string. Let me walk you through the problem step by step. We are provided with a string S that can contain both uppercase and lowercase letters, along with other printable ASCII characters. Our task is to reverse the order of all vowels in the string, while keeping the positions of non-vowel characters unchanged. Now, let me clarify what we mean by vowels. For this problem, vowels are the characters A, E, I, O, and U, including both their uppercase, A, E, I, O, U, and lowercase forms. So, let's see what is going to be our approach. To solve this efficiently, the most common solution is the two-pointer approach, which works like this. Start with 2 pointers, one at the beginning of the string, the other at the end. This approach ensures we traverse the string only once, giving us a time complexity of big O of n, where n is the length of the string. So these 4 conditions will make up most of the solution to this problem. So understand it with full focus. If you get this part, you will solve the problem easily. We will be looking at 4 conditions in this solution. First, when both of our pointers point to vowels, we will swap the vowels. Second, if only the front pointer is pointing to a vowel and the last pointer is not, we will decrement the last pointer until we find a vowel by decreasing it by 1. Third, when the last pointer is pointing to a vowel, we will increment the front pointer until we get a vowel to swap with. Finally, when neither pointer is pointing to a vowel, we will decrement the last pointer and increment the front pointer. And yes, if you have understood this approach, you've solved more than 70% of the problem. Now we will just code it. If not, I would encourage you to go back and review the approach once more before continuing. So, suppose we have the example ice cream. Initially, our front pointer will be pointing to the character I, and the last pointer will be pointing to the character M. In this case, we observe that the last pointer is not pointing to a vowel, so we encounter condition 3 of our approach. Hence, we decrement the last pointer to move it towards the next character. Now, the front pointer is still at I, and the last pointer moves to B. At this point, both pointers are pointing to vowels, so we encounter condition 1. According to this condition, we swap the letters IJ and D. After the swap, the string becomes ACREI, and we increment the front pointer and decrement the last pointer. Next, the front pointer points to C, and the last pointer points to E. Here, we encounter condition 4 because neither of the pointers is pointing to a vowel. In this case, we increment the front pointer and decrement the last pointer to find vowels. Now, the front pointer points to B, and the last pointer also points to E. This is condition 1 again, so we swap the vowels. Since both vowels are the same in this case, the string remains ACREI, but we still increment the front pointer and decrement the last pointer. At this point, the front pointer has crossed the last pointer, which means all the vowels have been reversed. The final string after processing all the vowels is ACECREI. So, let us quickly code it. Here, I already have the basic code with a class LT75 and in main function a string S storing ice cream, which we will pass to a function called reverse vowels to get our output. Now, let us build the reverse vowels function step by step. Create a character array. First, we will create a character array to store all the letters of the string. This will allow us to easily swap characters, as strings in Java are immutable. Initialize 2 pointers. Next, we will initialize 2 pointers. Front will be set to 0 to point to the first letter of the string. Last will be set to length -1 to point to the last letter of the string. Create a while loop. After this, we will write a while loop that will continue until the front pointer becomes greater than the last pointer. The loop ensures we stop when all vowels have been processed. So we write condition as up till front less than last this loop must run. Write down the 4 conditions. Inside the loop, we will handle the 4 conditions from our approach. Condition 1. If both front and last are vowels, we pass them to an isVowel function, which we will be creating. So we pass chars of front to vowel and chars of last to vowel and check their AND operation. If it returns true, means both pointers are vowels, so we will swap the vowels. So, let us quickly create the function isVowel. We will define the isVowel function to be Boolean to return true if it is a vowel, else return false. This function will accept a character C to check if it is a vowel. First, let us complete writing for while loop conditions. So in this case 1, if we get both to be vowels, we will swap the letters. Condition 2. We write in the else if loop if only the chars of front is a vowel, we decrement the last pointer to find another vowel to swap with. So we write isVowel and pass chars of front to check. And we decrement the last if this condition gets true. So as it turns out to be true, we write last minus minus terminator. Now, let us similarly write down our condition 3. Here, if only the last pointer points to a vowel, we increment the front pointer until we find another vowel. So we write isVowel function and pass chars of last to check and increment front at true. Lastly, our condition 4. We write it in else loop as, if neither pointer points to a vowel, we increment the front pointer as front plus plus and decrement the last pointer as last minus minus to continue searching. So let's complete our swap function. We will be swapping by our traditional method using a third variable as char temporary as temp, which equals to chars of front front, and then we write as the chars of front equals to chars of last last, and then we write as the chars of last equals to temp temp character, which completes our swap. And at last we will return the same character array converted to string as return new string in parenthesis characters. So this is inbuilt function to pass characters array as a string. So we write new string string cha our schars. Now, let us finally complete our isVowel function. It accepts a character C. So we write the if condition as if C equals to a, or C equals to a, or C equals to E, or C equals to E, or C equals to I, or C equals to I, or C equals to O, or C equals to O, or C equals to U, or again the same to you. So we will return if any one of these conditions is true as return true, else we return false false. So yes, this completes our code. But we would like to do one optimization here as directly select this whole condition and put it in return as it will directly return true if vowel and false if not. Okay, cool. So let's see the whole code at a glance. What we did. We firstly made function reverse vowel that accepts a string s. Next we made a characters array char to store all characters of the string, then we initialized out 2 pointers front and last. Then we have a while loop in which front is less than last. Next we check the 4 conditions as first in which both characters are vowels, so we swap. Next, if front is a vowel, then we just decrement the last next condition. If the last is a vowel, then we increment front, and lastly, if neither of them is a vowel. And on the top finally we have our isVowel function to check if a character is a vowel and return a Boolean output. Now, let us quickly run it. So we open the terminal and run the command as java filename.java. As in my case is java lt75.java. So, yeah, I think we missed something as it's taking a lot of time, okay? Yes, we need to increment front as plus plus, as well decrement the last as minus minus after swapping to check next characters. So, okay, now let us compile and run again. Great, aha, here goes our output. So do like, share, subscribe, and keep coding.